Okay, so this week's lesson is on matter, the properties of matter, and the phases of matter. So first we talked about how to think like an alchemist. Remember that an alchemist was not a scientist. This was before chemistry existed. They were often hired to do things like turn rocks into gold or create a potion that could make someone live forever. But they were technically doing science early on, writing down everything that they learned as they went along the way, mixing different elements and different compounds. Okay, so vocabulary. Matter is anything that has mass and takes up space. Inertia, it says the property of matter where it resists a change in motion, it should say. This word should be motion. So in other words, if I jump out of my car that has died and I try to get it moving, it's going to take me a little while to get it moving. And that's inertia. Once it gets moving, I would not run in front of it and try to stop it, because once it's moving, it would try to stay moving and it would be very hard to stop it. Alright, physical properties of matter. Physical properties can be observed without changing the matter. Conductivity, in other words, does heat or electricity flow through it? The state and the physical form as far as gas, liquid, solids. Is it soluble? Can it be dissolved is what that means. Is it ductile, or does it have ductility where it can be pulled and twisted into wire? Or is it malleable? Can it be hammered into thin sheets? Metals are ductile and malleable. Salt, sugar is soluble. Alright, physical change is one that affects one or more of those properties. Alright, matter's ability to change into a new substance with whole new properties are called chemical properties. Examples being flammable, can it burn? Reactivity, does it explode or combine with another element or compound? A chemical change is another word for, or term for, chemical reaction. These are the ways that you can tell a chemical reaction has taken place. Change of odor, heat, fizzing, foaming, sound, light. A physical change can be reversed easily. If I melt an ice cube, it's very easy to freeze that again and get an ice cube again. But a chemical change can usually not be reversed at all. And if it can be reversed, it's only through extreme chemical reactions. Okay, the phases of matter are also called the states of matter. A solid is defined as having a definite shape and a definite volume. A book is going to always stay the shape of a book. And it has a definite volume. I can measure the length, width, and height. The atoms in a solid are all packed tightly. They still move, they vibrate back and forth, but they are still tightly together. An amorphous solid is the only one that can change its shape. It acts like it's a liquid. Example would be slime, candle wax, glass, that's an example. Liquid has a definite volume. I can measure out 10 milliliters, but it has no definite shape. It takes on the shape of the container. The atoms in a liquid are packed loosely. They slide past one another. Viscosity is defined as the resistance to flow. Honey has a high viscosity because it flows very slowly. It resists flowing. Water flows easily, so it has a low viscosity. A gas has neither a definite volume nor shape. We cannot measure out 10 milliliters of gas, and it takes on the shape of the container. Atoms in a gas are spaced out far apart. This is why it's easy to walk through the air. Don't worry about Boyle's or Charles' law. We're not going to include those. But do know that as temperature rises, the atoms speed up and spread out. Plasma is made up of charged atoms, also called ions. It's rare on Earth. Lightning would be our only example, and this is what stars are made of. So out in the universe and space is very abundant, meaning there's lots of it. A change of state can only occur as the atom's movement changes. It is not directly related to temperature. So the movements are either speeding up, causing something to melt, or they're slowing down, causing something to freeze. How do we know this is true? Freezing and melting both occur at 0 degrees Celsius. If this were true that the temperature is what caused it, they couldn't both happen at 0. Okay, melting is defined as from a solid to a liquid. Water melts at 0 degrees Celsius. Freezing is liquid to solid, again at 0 degrees Celsius. Evaporation is a liquid to a gas. Boiling is also a liquid to a gas. How do we know they're different? Evaporation occurs at the top, and boiling occurs at the bottom. If you've ever watched something boil, you see the bubbles form at the bottom of the pan and eventually float up. Boiling occurs of water at 100 degrees Celsius. Sublimation is from a solid to a gas, and condensation is from a gas to a liquid. Example of sublimation would be dry ice. It's solid CO2 and it's released as the fog, the gas form. It does not melt into a liquid form first. Condensation example would be dew on the grass or clouds. Okay, so remember this diagram. Down here we have heat energy, and as it moves over here, they speed up. So they're fast on this side. I'm trying to write this with a mouse, so it probably looks weird. Up here, it's condensing. I don't know if I can do this with the mouse. And down here it would be boiling. So we would say that the gas is up here. Liquid would be here. This one is melting. Oh, I'm sorry, freezing, because it's slowing down. And then this one's melting, because they're speeding up. And over here would be our solid. Okay, hopefully you can read that. Okay, that's it. That's everything that we're covering. I'll see you tomorrow. If you need to listen to this several times, do that. If you need to watch it, do that. If you need to make flashcards, you better get started. See you tomorrow.